Hey there, ninth graders from St. Paul American School Clark. Welcome to today's Explainer. We've got a fantastic geometry breakdown lined up for you, specifically diving into Unit 5, Lesson 9. So we're going to be unlocking the secrets of the unit circle today. And the best part, you won't have to memorize every single coordinate. If you've ever stared at a fully filled out unit circle and just felt totally overwhelmed by the fractions, the radicals, and the positive and negative signs everywhere, well, you're in exactly the right place. We're going to simplify the whole shebang using just two main concepts. Okay, let's quickly map out our agenda for this explainer. First, we'll cover the unit circle cheat code. Then, symmetry and reference angles. Third, solving for 150 degrees. Fourth, we'll look at how to avoid these common traps. After that, we'll test your knowledge and finally do a core concepts recap. Let's get into it. Section 1, the unit circle cheat code, setting the objective. The big goal here is realizing you don't need to memorize the entire 360-degree circle. Instead, we're figuring out how to navigate the whole thing using just the first quadrant as our master key. Once you have the coordinates for those basic acute angles down, like 30, 45, and 60 degrees, you can literally unlock any other major angle on the map. Moving right along to Section 2, symmetry and reference angles, the master key. Let's see how these concepts build our understanding of the circle as this perfectly symmetrical map. The unit circle is basically built on reflection and symmetry, and the ultimate tool we use to unlock all of that is called the reference angle. So here's the formal definition. A reference angle is simply your shortest path from your angle's terminal side, which is really just the line where your angle stops, back to the flat ground, which is always the x-axis. No matter if your angle ends up pointing up and to the left or way down and to the right, you just want to find the smallest, tightest angle that takes you straight back to that horizontal line. And because it's the absolute shortest path, it's always an acute angle. It's strictly between 0 and 90 degrees. And depending on which quadrant your angle actually lands in, you can find that shortest path using these formulas right here. Let's break this down a bit. If your angle, theta, is already in quadrant 1, well, it's already between 0 and 90, so it's just its own reference angle. Easy, right? Now, if you land in quadrant 2, you haven't quite reached the 180-degree mark on the left side, so you just subtract your angle from 180. If you're down in quadrant 3, you've gone past 180 degrees, so you take your angle and subtract 180 to see exactly how far past the axis you went. And finally, if you're over in quadrant 4, you're falling just short of a full 360-degree rotation, so you subtract your angle from 360. Now, think of the unit circle kind of like a folded piece of paper. If you were to fold it across the y-axis or the x-axis, the coordinates for these reference angles would line up absolutely perfectly. Because of this built-in symmetry, angles share the exact same cosine and sine values as their reference angles. It's practically a cheat code. The only thing you have to do is adjust whether those values are positive or negative based on the specific quadrant you landed in. The magnitude, the actual numbers in the coordinates, stay completely identical. All right, Section 3, solving for 150 degrees, the worked example. Let's actually put these rules to the test and find the reference angle and trig values for 150 degrees. By following these 4 simple steps, we can easily conquer this one. Step 1, 150 degrees is clearly greater than 90 but less than 180, so we know for sure it sits right in quadrant 2. Step 2, because we're in quadrant 2, we grab our specific formula, which is 180 degrees minus our angle. Step 3, we do the math. 180 minus 150 gives us exactly 30 degrees. Boom, that's our reference angle. 150 degrees is exactly 30 degrees short of the flat horizontal x-axis. Finally, step 4 tells us to use symmetry to find our positive or negative signs. And this is where the symmetry perfectly proves our work. We know from quadrant I that the sine of 30 degrees is 1/2 and the cosine is radical 3/2. Now, because 150 degrees has a 30-degree reference angle, it uses those exact same numbers. But let's check the signs. In quadrant 2, your y value goes up, right? So sine stays positive. The sine of 150 is exactly the same as the sine of 30, which is positive 1/2. But in quadrant 2, your x value goes to the left, which means it's negative, so the cosine of 150 degrees flips to a negative radical 3/2. Same exact magnitude, just a different sign. Moving on to Section 4. Avoid these common traps. Misconception check. Before you go trying this on your own, we really need to talk about some of the biggest pitfalls geometry students fall into when they're doing this for the very first time. Honestly, the absolute biggest mistake you can make is measuring your reference angle to the y-axis. Remember what we said earlier. A reference angle is always measured to the nearest part of the x-axis, never the y-axis. So, for example, if you have an angle of 120 degrees, the correct reference angle is 180 minus 120, which is 60 degrees. The trap here is thinking, oh, well, 120 is close to the 90-degree vertical line, and doing 120 minus 90 to get 30 degrees. Don't do it. That'll give you completely wrong coordinates. Always measure back to the flat ground. Another super common mistake is doing all that hard work to find the reference angle, but then just completely forgetting to adjust the positive or negative signs for your new quadrant. To make absolutely sure you don't forget, memorize this classic mnemonic, ASTC, or All Students Take Calculus. This tells you exactly which functions are positive in which quadrant as you move counterclockwise starting from the top right. Quadrant I starts with A, meaning all functions are positive. Quadrant 2 is S, so only sine is positive. Quadrant 3 is T, meaning only tangent is positive. And quadrant 4 is C, so only cosine is positive. It's a real lifesaver. All right, section 5, test your knowledge, formative check. Let's just pause for a quick second to see if you've truly grasped the core rule of today's explainer. Think back to the definition we covered earlier and ask yourself, is a reference angle ever negative? Say you have an angle like negative 210 degrees. Could its reference angle be a negative number? The answer is a definitive no. Because a reference angle represents a physical magnitude, or the angular distance from the terminal side to the x-axis, it strictly has to be a positive value between 0 and 90 degrees. Even if your original angle is negative, your reference angle, that shortest path to the x-axis, is always just a positive distance. And finally, section 6, the core concepts recap, final takeaways. Let's wrap this up by summarizing exactly what you need to remember to completely nail Unit 5, Lesson 9. Make sure to lock in these foundational points. First, reference angles are your absolute shortest path back to the horizontal x-axis, keeping you right between 0 and 90 degrees. Second, use your specific formulas depending on your quadrant. Subtract from 180, subtract 180 from your angle, or subtract from 360. Third, remember that the unit circle is perfectly symmetrical, meaning the reference angle hands you the exact numerical values for sine and cosine straight from quadrant I. And lastly, the quadrant your angle lands in is the ultimate decider for the positive or negative signs, which you can always double-check using that all students take calculus trick. So, if quadrant I is basically the master key to the entire map, which coordinates are you going to unlock next? Now that you have these unit circle cheat codes, what complex angle are you ready to conquer? Thanks so much for joining me on this explainer, 9th graders. I'll see you next time as we keep exploring the awesome world of geometry.